and welcome to our privacy and information security project. So in this project we have made a healthcare system using a blockchain to store patient records. So this is how we should run the app. So just python app.py, and now we can see all the features available, like we've got the ability to add patient records, search for a particular patient's history, and we have minor leaderboard. So in this system we have what we have implemented is that instead of having only one person look for the correct block, we have four parallel processes running. So each of the four processes checks for random nonces which can satisfy the blockchain property. Alright, so let's first of all take a look at the blockchain. So using the blockchain explorer you can see all the details like the timestamp, the previous hash, the hash of this particular block, the nonce which the miner discovered, and the signature. So in this case what we are doing is we are signing each block using RSA for the private public key scheme. So what it does is that we can ensure that the block was not modified or altered. So we've got all the block details here, and now we can see that there are a total of 7 patients at the moment in the list. So let me add another one, just the patient ID, and we can provide a name, so just a random name here. You can select what type of record it is. Let's say it's surgery, and just add record. Now while the record is being added, and see that it has started mining for block 8 with difficulty 4. So I'll explain what difficulty is in a little bit. So the record was added. So now if we check the blockchain explorer again, you can see that the latest record I added just now, it is totally visible here. Now let's take a look at the miner leaderboard. So in this what we have is what are the blocks that were mined, and which one of the miners, so the parallel processes which were running, which one of them managed to get the right nonce which satisfies the property. So since the difficulty was 4, the difficulty refers to the number of zeros at the beginning of the hash. So since the difficulty was 4, we had 4 zeros. So what I have set up, what we have set up, it has a possibility that the difficulty can either be 4 or 5, because I found that if the difficulty is beyond 5, it generally takes too long to mine. So I've kept the difficulty restricted to a maximum of 5. Like this particular block, it has a difficulty of 5. And we are also providing the miners some rewards, like it is done in real blockchain systems. So the reward is 100 for difficulty 5 and 10 for difficulty 4. You also look at the blockchain data in JSON. So this is just the raw JSON file which we can download and export to other systems. And now for searching for patients, let's say we enter some particular patient ID, let's say 8, and now we can get all the details of the patient. So all it does is it just compares the ID given with the IDs present in the blockchain. So this is what the system is like now. Another thing is validating blockchain integrity. So if a particular block was altered after the block was made, so what will happen is that the hash of the current block will change, which in turn will change the previous hash of the next block. So that should in effect break the whole system. So this particular function, it provides us a way to check whether the blockchain is valid. So I clicked on check, and now we can see that the blockchain is valid. So I'll explain exactly how it works in a little bit. So let's go through the code. So at the beginning I just have a function which generates keys, so the private key and the public key for signing the particular block, just loading the keys, signing the data using standard approaches like private key dot sign, padding dot pss. So we use this SHA-256 as the basis for signing the block, and this is the function for verifying the particular signature. Obviously we must have the same parameters as those in signing. Now let me explain the blockchain itself. So we are loading the old blockchain and the miner file in case it is already present in the system, like here it is. Now while creating the block, we have the index, timestamp, data, previous hash, the hash of the previous block, and the nonce, and setting a difficulty at random, which can either be 4 or 5, and setting a reward for the particular block. Now the proof of work function is run. So what this function does is that it starts four processes in parallel. So there are four competing miners in some sense which are trying to get the correct nonce, so that the particular property is satisfied. Like, property we want is that the hash of the current block, it should start with four zeros if the difficulty is 4 and 5 if the difficulty is 5. And for that it is going to try random nonces. So all the four miners are trying random nonces. Whichever miner manages to get the hash quickest is given the reward, and that is how the whole mining process works. And you must also note that after the proof of work is done, so after we get the correct hash, so hence the correct nonce, after that we are going to sign the block. So we create a copy of the block, and then the block is signed using the public and private key I showed just now. So the block is signed and it is added to the chain. And finally, let me also describe how the block's validity is checked. Yes, so the few things we check are, first of all, the previous hash of the block has to be equal to the current hash of the previous block. So this can help to detect if there are any forgeries in the block. And then obviously we have to check the proof of work as well. So just check whether the hash of the current block does indeed start with the number of zeros stipulated by the difficulty. Next is checking whether the hash is consistent. So for that we are going to copy the block and the signature separately. Now remove the hash and then recompute the hash again. Recompute the hash for that block and then check if the stored hash and the computed hash are the same. Finally we verify the RSA signature. For that we get the data which was signed, and we use the verify signature function to check whether the signature is indeed correct. So we pass the signed data, the signature, and the public key to check whether the signature was correct. So we can run this for all the blocks in the chain to check if the chain is valid. So this was the basis for the validate blockchain function. And the backend otherwise is quite simple. We just have some functions for adding record, getting the chain. So when we print the blockchain explorer, this function is called getting the patient ID. So we just check the blockchain for that particular ID, displaying the miner statistics, and etc. The main target of this project was to demonstrate how a blockchain works, and demonstrate how it can be used in real world scenarios. So some of the things we could try in the future are trying to make sure that multiple clients can add patients to the blockchain at the same time. So for this we will have to implement protocols which verify which is the largest version of the blockchain currently in use, and that is assigned by default to be the current running version. We can also try to use proper certificates for the website. So although I am using HTTPS protocol here, the protocol is actually like we have generated the certificates on our own, so they are not recognized by the authority. Hence it says it's not secure. So we can try and get a certificate from a real authority. Yeah, that was it. Thank you.